One of the biggest highlights for us at AUVSI Xponential is talking to MITRE Opengen lead, Ajit. And we're going to get into his background and just what MITRE is working on and what we're doing and what they're doing in Opengen. So glad to have you join us today on ZeoCast. Absolutely. Tell us about your background. I mean, you've got a background in engineering and innovation and applied sciences. How did you get to this particular role now as heading up Opengen?
Well, it's been a long journey. I think it all started when I went to Georgia Tech, and I was an electrical engineer, and I started working at Motorola as a co-op and actually doing two-way radio studies with public safety. And actually back in those days, computers were pretty new, in fact, and so you did some things on computer, and most of the time you actually went through topo maps and would get the elevations yourself and calculate the propagation manually.
Right.
So I started with that, and then after I graduated, I went to Chicago and headquarters and started working international and doing more public safety work with the Jamaica Police Force, Malaysia Police Force, and doing actual implementation of the public safety systems internationally. And from there, I kind of rolled into what became IDEN, what Sprint originally had, and the IDEN network, but back then it was called something different, and that was all a cellular backend with Motorola proprietary radio.
Okay.
And I moved from there into cellular, and from then I went internationally and did radio planning and system engineering in Asia, in China, and Hong Kong, and Singapore, Malaysia, just all over the world literally, and did that through the late 90s, and then I went to England, and I started getting into, that's when 3G started.
Wow.
Right? And we were moving from 2G to 3G, and we were also at the same time, that was the beginning of the first data on 2G with GPRS, where instead of circuit switch data, we'd have packet data. So we started demonstrating the first data connections using packet data on 2G, and we were also demonstrating the future networks that 3G were bringing.
Okay.
So I did that for about a year, and then I decided to leave Motorola. I went back to the United States and did a startup company in Boston and went through the whole venture funding world and helped raise money, and did that for a couple of years before I then moved to Nokia and went back to China, strange enough, and again working there in more of the standards and regulatory area, and working with the Chinese regulators and the Chinese government and Chinese customers with what Nokia was making, and making sure there's good alignment on the requirements and trying to keep the standards that China was developing in line with the international standards, right? So that it makes it creates a better ecosystem for everybody,
right,
because all the equipment can be sold all over the world. So I was there for a number of years, and then moved back to Atlanta in 2006, and continued to, then I kind of moved into innovation after a few years of doing standards here in the US, and we set up a innovation team around software development in Silicon Valley, and we started building in 2009, 2010, big data systems, trying to analyze all the data on the cellular system at scale in real time, which was a tremendous amount of data, a lot of data points, and trying to figure out what we can learn from that, how we can optimize the network, how we can plan for sudden peaks and valleys and network traffic, and also discovering where people were, because around that time was when GPS and phones really was taking off. And then we could actually know where our users were, which we really didn't know before. We kind of knew, but we really didn't know. So like, oh, people are really here. So maybe we can plan to put a cell site here, because we really see that based on GPS data that users are in this area that we didn't have knowledge of before. So it's getting smarter about how we do networks and network design, network planning.
Wow, what an incredible background.
Yeah.
I mean, you're obviously very well prepared for the role that you're in now. So tell us a little bit more about Opengen, 5G, the consortium, and what you're looking, to the outcomes of this.
So Open Generation was created a little over a year and a half ago, and the purpose of Open Generation was we realized that 5G really needed a consortium model to make it happen, because if you think about 4G, it was driven by the app economy. 5G is going to be driven by enterprise applications, and that's a lot harder, right? And how do you get those experiments in the real world so that enterprise users can can see what they can do, right? So we approached a number of the leading vendors in the space, and we had our founders, which was Verizon, Nokia, and Ericsson, that came on board to start, and then we added Qualcomm and added 2 universities, Northeastern and Virginia Tech, and your company, Zio Air, in this last year, as well as Thales, to the consortium, and we continue to build it out. And the idea around Opengen was, we have hard problems. How do you solve hard problems on your own? In this new world, it isn't about, I know the radio, and I know the application, and I know the transport. You really have to work end to end, right? And Opengen, the people that joined early on saw that the vision of, we have different verticals. We have drones with UAS, we have public safety, we have telehealth, we have intelligent transportation. These are all new areas where now, in the 90s, we talk about how the internet crosses all verticals. Now it's more, how does 5G cross all verticals, right? And what does that mean when 5G is there? What does that enable?
Well, I mean, this is a hot topic in almost every conversation that is being had around drones and autonomous systems. When you think about this convergence of advanced tech, cybersecurity, I mean, there's not one area that is not being touched by the other. What do you see as the long-term, outcomes, implementation, execution, and then the revenue strategies of how all this is going to, come together? How do you see this coming together?
Well, that's a big question.
It is a big question.
It is a big question. So, cybersecurity, just to start with that one, that's kind of a baseline requirement now, right? And MITRE's done a lot of work from an adversarial approach to cybersecurity to see how we attack networks and installations to find the vulnerabilities using known vectors that the bad guys like to do. But when we think about drones, it's really important, right? The network has to be secure, the actual drone itself has to be secure, that command and control link can't be compromised anyway. The pilot, the aerial ID or the remote ID of the drone, that can't be copied. There's a lot of things that we have to worry about from a drone, and also with the network in play now from the bigger security area, it's not a man or an operator looking at a drone and flying it. They can be in another city and flying it. So it opens up a whole new area of discussion about security in general. But when we think about security, that's something that I think isn't paid enough attention to. The cellular industry is pretty adamant about security, and we're very careful. We keep evolving and trying to keep ahead of threats, but when you start looking at these applications running over the network, not all the applications are as secure, and all the companies that may be working on it may not be necessarily aware of all the different threats that they may face once they're connected, right? Because it's different when, like in a drone case, I've just got a controller, I'm connected to drone, but if my drone is now connected to a cellular network, I also need to ensure that my application on the end isn't going to be compromised where the drone can be commandeered, right? And what was the other, unless you asked some other parts of that question?
No, I was just saying, it's an advanced tech in totality in terms of how all of these different technologies are kind of coming together. But cybersecurity really is at the center of all of this.
Yeah, if you think about 5G, it was built for enterprise. It was designed with the idea of AI being a big part of the cybersecurity, or the 5G world. Cybersecurity is an important piece. Then the normal performance, better throughput, lower latency, higher bandwidth capabilities, the ability to even slice the network in a way that everyone has a slice for their application that they can run in their own way versus the general network. So depending on the application and the user type, network slicing is also a very important piece of what 5G brings to the table, where let's say you're a public safety officer or agency and you're running your application, your mission, that could be on a network slice, and maybe it might be that when there's a critical response requirement that slice gets upgraded then to having high priority, right? So that end-to-end everything is running at a higher grade of service than the other users. Or if you're an ambulance, normally you might be running it normally, right? But then if you're transporting a patient and there's the requirement for real-time telemetry and data, then the network would be requested to give you higher priority, right? And if you wanted to do video and other telemetry, then those segments of that connection need to have that kind of additional priority and greatest service, so that there's no degradation to that video feed, as an example, or if it's a heart rate monitor, whatever the telemetry needs to be brought back.
Well, one of the other things that continues to come up in conversations that I'm having about drones and 5G, and particularly, is rural versus urban. And there's a definite need and use case for the rural environment, and clearly all the ones for the urban environment, to your point, from public safety to drone delivery. How do you see this rollout happening between urban environments and rural environments? And will it really be driven more, because I know it's usually by demand.
Yeah.
How do you think this is going to play out? And will these be public-private partnerships? Will this be driven by the needs of the use case, like a medical use case gets higher priority? How does it happen?
I think industries and the government have always been working on this. The FCC's had a broadband fund and has a broadband fund to help fund the development of rural broadband. MITRE has also been working in this area to ensure that there's good equity for all Americans, that it's not, you can't be in a broadband desert, right, as such. It's important for the economy, right? Obviously the urban areas will naturally get 5G faster because there's a capacity requirement and there's a density. So I think we need to think about it maybe in a few dimensions. One is, in the urban environment, we need a lot of capacity, and we need and we have higher density of users. So the 5G spectrum in that area can be different than the 5G in the rural, because 5G is not necessarily spectrum dependent, right? So we could be running millimeter wave in an urban area because it gives high capacity, but we won't probably use millimeter wave in the rural area, because you need lower wavelengths because you want to have the coverage, right, in that area. So you can still run 5G, but it will be on a lower frequency band that can provide more ubiquitous coverage, because millimeter wave doesn't go very far. It has a lot of bandwidth, but so in the urban environments, much more economical and makes sense. In the rural area, we pick the right radio, we put the 5G on it, and then it really is going to be driven by what the government is encouraging and bringing from state and local all the way to the FCC, and then the operators themselves obviously are building out their networks, and LTE is still going to be available for a long time. 5G doesn't have to be a replacement for LTE. They can both coincide, and then over time the economics of 5G will continue to get better and better as equipment gets older, that you would want to deploy 5G everywhere, right?
Sure.
Yeah, and that's a natural cycle from 2G to 3G to 4G and now to 5G, that we continue this cycle of taking equipment offline, bringing in new equipment, because the economics of the new equipment is better, because you get energy efficiency improvements with new equipment, which is important. You get obviously more capacity and capabilities in the radio. But the way the networks are deployed, they can coexist, because we are backwards compatible as well.
Well, when you think about this incredible demand that there will be for spectrum between drones and advanced aerial mobility, robotics and the like, how will edge computing play a role in how this becomes more sophisticated and have better execution in real world?
Right. Well, since we're at AUVSI, let's talk about drones, because that's a good example.
Yeah.
So let's think about distributed computing. So there's going to be compute in the drone. There can be compute at the base station or at the network edge, and there's going to be cloud compute on the far end. So depending on the mission and what you want and the battery and power profile you have, you could decide to do some compute, like let's call near real-time computing on the drone for, let's say, detect and avoid, right? But then you can do drone swarm management and from the edge of the network, because you can see all that and you can process all that with AI at the network edge. And then finally you have the cloud, which can look at a whole swath of drone capabilities. So then the question then becomes is, what do you want to do with the data? So I have a video feed, right, for example, or I have thermographic information from a building inspection. So I don't necessarily need to process that on the drone. I just want to transport that. So I can edge compute that, either in the network or in the cloud, and then I can take that information and use it for what either operator purpose or for the engineer who's looking at the building infrastructure.
Okay.
Right, because we want to make sure that the drone itself, as an example, has a power budget, and you want to decide how much of that power budget you want to use for compute for the application and how much you want to offload, right? So this is where edge computing and AI and aggregation of, think about it, not just even single drone missions, but multiple drones in an area or hundreds of drones and all those streams coming through, and then you want to be able to aggregate that, run machine learning algorithms on it, and do your detect on whatever objects you're looking at, and then you can then instruct the drone on command and control, go look at this, or move away, because right.
I could ask you about 20 more questions just based on that on that answer,
Yeah.
but I'll reserve that when I have you
Yeah.
back on. What do you think are the biggest barriers that are, that are in the way here? The biggest challenges that, the industry faces in providing, that kind of smooth operation?
Yeah, I think it's a learning process in the industry that kind of began when LTE started, but it's kind of funny. LTE was not really built for it wasn't envisioned that we would have these kind of iPhones and the Facebooks. That was not what LTE was really thought to doing. It was actually kind of more, internet connectivity, right? Better internet connectivity, and then the internet happened that way, and we're like, oh, we need to change, and we need to change our packet sizes and information there. And as 5G goes, maybe it's AR, VR that drives those use cases. But the learnings the industry is coming at this, you can see in private LTE networks and private 5G that industrial automation, the tight latency requirements that they may require for the robots to work with each other is going to be a use case driver, and doing that locally. In the public network, with drones, for example, obviously beyond visual line of sight, and having that the regulatory environment around that clearly defined is what's going to make that really go forward. Because if you think about the alternatives for beyond visual line of sight flight, you can use satellite, but that's kind of heavy, and there's a big dish or antenna system,
right.
And satellites do get blocked as well. They're not perfect. The cellular network is the most ubiquitous communication system that's available at scale and at economy that you have, right? So that helps with the drone mission. The regulatory requirements need to be clear so that we can do beyond visual line of sight, and the data that we've been collecting, like through the different ARC charters as well as what we're going to do at Opengen, will help the regulators to understand what the safety profile is, right? Because and that's going to be, I think, for drones, the important thing. The other things that we see in drones that are going to come is there's I talked to a company that was a really interesting use case at the show. So there's a bridge here in Florida.
Yeah.
It got knocked out by a hurricane. There's a taco company on one side of the bridge, and the entire neighborhoods that want the tacos are on the other side of the bridge. It takes 35 minutes now to do a trip to buy your tacos. So people were like, hey, how do I get these tacos? So this company called this drone service and said, can you deliver tacos across? Because across the bridge is like 10 minutes to deliver tacos. So it became a use case, right? And they're delivering tacos, not beyond visual line of sight, but line of sight. But they tether and they drop the tacos down, and people get their tacos, and they've solved a real problem, right?
Oh, that is awesome.
So is that a use case? I mean, the taco use case, it's lightweight, right? It's not coffee, which is heavy, but but I think that's an interesting one. Like the industry's still learning, like, because we've been considering drones like, oh, I'll go and fly it over my house, and I'll get my realtor pictures. Infrastructure inspection today is just starting. That the states and the local governments are just realizing how much money they can save with the drone versus having people climbing and taking pictures, and they can do it more often and ensure the inspection there. And that's a very localized drone use case, but again, with the cellular network there, that would make it that you don't really need to necessarily worry about the ability to fly your mission. You always have that network. So that's one. I think there's a big new area around AR, VR, that's coming, that the 5G network is going to make happen because of the way the use cases that are there, even around gaming. Wi-Fi doesn't meet those kind of requirements, so being able to offload, like if you think about a totally immersive AR, VR environment where you're in a big room and you're wearing the goggles and you're moving with other people in space, you need a really high-end radio connection and low latency to be able to carry all that data, because otherwise you're carrying basically today you're carrying a very heavy computer on your backpack, right, to do all that. So that changes what you can do. So I can see all these different industry points that are pointing to, I need something better.
Right.
And they're kind of like green shoots, right, at the moment. So we haven't yet got to, like, no one's come with, like, here's the killer 5G use case, because when LTE came out, there was no killer LTE use case either. The iPhone turned out to be the creator of the platform for those use cases, right?
Well, you know, while that taco example is it's tacos.
Yeah.
You're not saving the world. No offense to the taco stand. I like to get a taco, but if it demonstrates it, and someone else said this earlier in one of our interviews, if you can do that, that shows us what else is possible.
Right. You can deliver drugs.
Exactly.
I'll give you another great use case. So nursing homes get drug deliveries all the time, right? And it costs money for the distributor to send that, but then if you run out of drugs, which happens, then for them to roll a delivery truck just to deliver, one package is actually really expensive, right? It's going to cost you $100, and that's something somebody has to pay for. But a drone delivery of that package from that distributor, so it's not like I'm just delivering to any random house in a neighborhood. It's actually a very fixed flight path, right? That you're going to deliver to certain, B2B flight paths, right? That are going to be created in this new world. That drones will make a big difference in the cost and the delivery time, right? And the taco is just the simple use case of that. But effectively, if you can deliver a taco, you can deliver packages of drugs easily, right? And they're very lightweight. Right?
Absolutely. Well, my last question, and you get a little bit more than 6 questions, is what's your, and I ask everybody this question, what's your vision of the future? What do you think all this is going to look like in 10 years? Just, you're looking in your crystal ball.
It's never easy to see the future in reality because we're always wrong, as it turns out. But I would guess that in the future, in 10 years' time, one will be starting 6G, but to make up
even smaller nodes, even more closely packed together.
Right. But I would be very surprised if everything that moves doesn't have a cellular modem of some sort on it, that everything's not connected. Right, so we talk about the Internet of Things, but it's really it'll be the true Internet of Wireless Things that are networked, and the networking of those nodes in effect creates a whole new environment of sensors, right? So wireless sensors could be put everywhere that gives us weather information at microweather. We'll have city traffic information in real time. Intelligent transport with automation in the cars, because cars are going to be able to do vehicle-to-vehicle communication, so they can platoon. That's all using 5G wireless technology or some kind of localized technology. So I think everything will have some kind of radio on it, and it'll be interconnected from the smallest node to the largest being maybe a car or a truck. Right, and that the networking of those devices, that because they are connected, they can communicate with each other and they can coordinate with each other.
Okay, wow, that's a lot to think through, and I mean we're well on our way. But I don't know. Have you ever seen a time in your career where you've touched so much technology, where so much technology is converging together? Have you? I mean,
no. This is. Yeah, we are having, it hasn't been there because they've been very disparate, right? And they haven't come together. So we have communications, we have AI and machine learning, we have software engineering and cloud, and we have applications. So it is the first time where you really see all of these interwork in different ways. In the past, they've been very different, right? If you think back to the original cell phones, they're basically just devices that had a radio on it, and you just talked on them. That's all they did. And then eventually you took pictures and applications. They kept developing, but the connection of that device with the internet and that marrying of the two and the cross-discipline of working through that entire value chain changes things dramatically, right? I mean, what won't have AI on it in the future, right?
Nothing.
Right?
Nothing.
Yeah, nothing. I mean, there's AI in ovens even now, right?
Yeah, absolutely.
So,
Well, these have been your 6 plus questions. Ajit Kahaduwe, it's so nice to have you with us on ZeoCast, and we look forward to having you again soon.
Thank you.
Thank you, sir, and thank you for having us in the MITRE booth here at AUVSI.
Yeah, we appreciate having you.
Thanks.